All right. Hello, folks, and welcome to another edition of the Binding Status. We are excited to be here this week leading up to virtual KubeCon, where there's going to be lots of great talks. So we hope this is a good primer for all the awesome things you're going to see there. If you're not familiar with the show, we usually have a guest on, and they represent a project or an organization or something like that. And then we kind of see how that thing that they work on integrates well with Crossplane. Today, we have kind of a unique episode because Sascha and I work together quite a bit on upstream Kubernetes stuff and have recently worked together on some Seccomp functionality in Kubernetes. We're going to have some exciting news about releases coming forward on that. And Sascha is going to join us today, and we're going to look at what the Seccomp functionality has been changed to in Kubernetes, and also about the new forthcoming Seccomp operator. And we're also going to look at, obviously, as we usually do, how that can be useful to a project like Crossplane, but it's going to be pretty widely applicable as security is applicable to every workload you are going to run. Before we get started, I want to mention, as always, the chat is open. So if you want to introduce yourself, tell us where you're joining from, ask any questions, or suggest that we do things. I know that in live demos that we do every 2 weeks, I'm prone to make mistakes. So we're excited to have folks who are willing to correct our mistakes. So please feel free to do that. And without any further ado, I want to pass it off to Sascha, who is a senior software engineer at SUSE. Is that how you say it? I never know the correct way to say it, but I always
Yeah, that's
just change
correct.
it. I change it each time. So then, I get about 50% of the times right. But he's a senior software engineer. He's a tech lead of Kubernetes SIG Release. And he works on countless open source projects. I frequently find myself going to GitHub repo and finding him in the contributors. So lots of work that Sascha does, but I'll let him do a more formal and thorough introduction. So go ahead, Sascha.
Yeah, hey, thanks. Hey, friends. So this is, first of all, thank you for having me in the show today. So it's really a pleasure for me. I usually work on container runtimes like CRI-O and Podman, but I also contribute to the lower level bits of them. So therefore comes my interest in security related topics, especially around containers and also Linux for sure. But it's all about making them easier to use and applying stronger defaults. I'm also a Kubernetes contributor since 2019, and I started my journey in SIG Release, where I focused mainly on the release notes tooling in the first place. So I worked on many different release cycles for now, and later on, I decided to focus more on contributions on the release engineering parts of SIG Release. So this year, I had the pleasure to get promoted to become a technical lead in SIG Release, which allows us to grow the SIG more and concentrate our work more on tooling aspects around Kubernetes. Yeah, and I also want to contribute to Kubernetes in a more streamlined way. And we decided to graduate Seccomp this year to GA, which is pretty awesome and incredible. And yeah, I think I can hand over to Dan again.
Awesome. Thanks, Sascha. Yeah, Sascha does quite a lot of stuff in upstream Kubernetes. He briefly mentioned the release team there, which I've also had the privilege to serve on for a number of cycles now. One other thing I want to bring up is at virtual, I think it's Open Source Summit China, but basically the KubeCon flavor for the Asian market. We gave a talk kind of giving an introduction to all the different roles on SIG Release. And then next week, I'm going to be out, but Sascha, I think, will be doing Q&A for the talk that we gave. That's kind of a follow-up to that, that is more focused on release engineering, which we both have been involved in. And as Sascha mentioned, he is a lead on that side as well. So lots of awesome things to see there. The release team is probably the easiest way to get involved in contributing to upstream Kubernetes. So as this 1.19 cycle rounds out, be watching for applications to serve as a shadow if you'd like to get involved. All right, so enough about that. We are going to actually talk about Seccomp today, and we're going to start off with some slides. I'm going to do about half of them, and Sascha's going to do the other half. And so I'll go ahead and share my screen here. All right, let me move this out of the way. And cool. So, yep, we're going to be talking about Seccomp specifically in Kubernetes today. So, as kind of a brief overview of our agenda here, we're going to first give a bit of an overview about what Seccomp is in general, then talk about the history of Seccomp in Kubernetes, and then follow that up with graduating Seccomp to stable GA, as Sascha mentioned. And then what we're mainly going to be talking about today is the Seccomp Operator, which is the new project that we were discussing, and is going to be having its first release coming up here very soon. So I'll go ahead and start us off here with the overview of Seccomp. So as you'd imagine, typically workloads that you're running, whether they're in Kubernetes or just on your local machine, are usually running in user space, right? And if they need to do anything meaningful, they have to reach down into the kernel and say, will you do this important thing that you have the privilege to do, essentially? And since they do that, and there's an isolation level there, that's kind of an opportunity for filtering on what a process can ask the kernel to do on its behalf. So there are lots of syscalls in the Linux kernel. We're going to look at some of them in a searchable list later on when we're crafting some Seccomp profiles. But typically, any workload that you run is not going to need access to all of them. In fact, it'd be rather concerning if a workload did need access to all of them. So what you want to do is evaluate what syscalls it does need access to, and then restrict it to only those ones. So anyway, the way that happens is you write a profile that either has an allow list or a deny list. We'll talk about some of the configuration there that says when I ask the kernel to do something on my behalf, evaluate if it fits within the parameters of this profile. So Seccomp has been around for a little while. All the way back to 2005 is when it was first initially introduced. And there's some websites where you can look up the full history of it. But essentially, the idea is that we want to make workloads run more securely and know exactly what they're doing down to the syscall level. As containerization has become more and more popular, this is especially useful because essentially what we're doing with containerization is putting our workloads into a sandbox, right? And we might even have an orchestrator running on top of that, like Kubernetes, that is placing those containers onto nodes that are, running operating systems that have a kernel, and we're reaching down into those. So being able to apply a Seccomp profile to a containerized sandbox is a very useful feature, but there are some rough edges around it, which we're going to talk about today. All right, so this is just a little bit more history of Seccomp and especially the filter syntax. So it's based on the BPF syntax, if you're familiar with Berkeley packet filter. And as I mentioned before, container runtimes pretty much universally support passing Seccomp profiles that are then applied to a container. And it is a JSON format, which we're going to look at momentarily. And the last thing that we want to note is that most container runtimes are going to have a default profile that says, this is a sane thing for a workload to do. And you can kind of get that out of the box, and we'll show how to apply that to containers in Kubernetes. You can also say, I know what I'm doing. Please take the rails off. I'd like to run as a privileged container, in which case you can kind of bypass that default Seccomp profile. All right, so this is the last one I'll do before I hand it off to Sascha here. But this is just an example of what a profile might look like. It's probably typical to any sort of, policy document that you've written, whether it be with, something higher level like OPA or an IAM role, or something lower level like this. You can see that here we're defining the default action. So we're saying, if this action is not classified in one of the blocks below, error here. We're also defining the architectures. So syscalls differ based on the architectures that of the machine. And then we're also defining a specific block here where we're saying for these two specific syscalls, we want to allow those to happen. Other things we'll look at later in terms of actions include logging those syscalls, which can be helpful when crafting a Seccomp profile. But you can have some pretty configurable values here to make the profile fit exactly the needs of your workload. So as I mentioned, Kubernetes, is scheduling these containers onto nodes, which have Seccomp enabled on them, and you have to be able to get those Seccomp profiles there and then apply them to the containers, and you're interacting with them at a higher level in Kubernetes, typically the pod level. So Sascha is going to talk a little bit about how Kubernetes interacts with Seccomp when you're interacting at this higher level, and also how Seccomp is changing in 1.19 and how the Seccomp operator is going to make some of these things easier. So I'll pass it off to you, Sascha.
Yeah, thanks. Thank you. I would like to give you, 1 second, let me share my screen. That should be. I would like to give another example of a Seccomp profile right now, just to highlight how complicated things can be just when we want to apply or change something on an architecture base. So it's possible in general to have fine granular rules based on dedicated architectures. So in this example, for example, we choose the clone syscall, and for S390, we have to switch the parameter ordering for the syscall at all, and that's how it looks like. So it's easy. It's not that easy from my perspective, and it gets complicated if we speak about different architectures and a different set of syscalls, because it can be different on those. But let's look a little bit of the history of Seccomp in Kubernetes. So the first proposal has landed in mid-2016. So this is already 4 years ago. And if you want to have a look, then you can just open that pull request. It's pretty interesting to dive into the history and look at some older stuff. But it generally tears down to having Seccomp profiles on a pod or a container level based on annotations. So we have always had the security alpha Kubernetes Seccomp annotation, and then we can specify it on a pod level, or we reference it by a container name and apply the profile on a container level. So pod level profiles will be overridden if we specify a container level profile. So it's possible to add something like a hierarchy for now. So we have 3 possible values. The first one is runtime default. So runtime default was previously, which is now deprecated, Docker default. And most container runtimes ship their default profile, which is pretty good. But the profile is as general as it can be. And sometimes it works, sometimes it does not work. And mostly users, if the runtime default profile does not work at all, they will switch to unconfined. So unconfined means that the profile is not existing. The feature is completely disabled. So now we could say, okay, why don't we just leave the annotation? This incorporates with pod security policies, because some pod security policies enforce default profiles. And then we could say, okay, the user has the possibility to still use unconfined Seccomp profiles if the workload doesn't work at all with the runtime default, for example. And as the third choice, we have our localhost profiles. So they are prefixed by localhost and a profile name. And they are in a directory on the local host machine, which is usually varlib kubelet and then Seccomp. But this is configurable by the Seccomp profile root flag on the kubelet. We decided to deprecate that flag, and it will probably be gone in 1.21. So in the next Kubernetes releases, we will probably have the default kubelet root and then a directory Seccomp where all those profiles have to be present. If the profile is not present on the local machine, then it's not possible to run the workload at all. So this is the main implication on that. So yeah, what happened since then? Not so much to say. The minimal testing, which is propagated. So if we run Kubernetes end-to-end tests and we exclude feature-based tests, then we have a feature-gate Seccomp. So we actually have to enable them. For example, in CRI-O, we decided recently to add those to our end-to-end test suite. Then we have some lacking documentation about the feature at all. So if you go to kubernetes.io, then you will probably not find many informations about Seccomp and how to craft those profiles. So this can be a problem as well. And we also had no beta graduation. So we were still in alpha phase for many, many years, and we didn't manage to graduate the feature to beta. So as a result of that, users will most likely stick to an empty profile, so not using the annotation at all, yeah, which is just running without the feature at all. And yeah, the other thing I like to mention is that a runtime default profile is mostly derived from the initial Docker implementation. So yeah, it's really hard to craft a profile which actually works for every kind of workload. So it's definitely worth the effort to look into crafting our own profiles. So yeah, we're working on graduating Seccomp as stable in Kubernetes. So, and we managed to do it actually, yay. So in 1.19, Seccomp will be stable in Kubernetes, which is really awesome. And now we have a dedicated field in the security context of the pod or the container. Now this looks like this. We have our security context, then we have the Seccomp profile, and we have our 3 types. So we have runtime default, we have localhost, and we also have unconfined. And if we want to run a localhost profile, then we don't have to prefix them with localhost anymore. We can just say, okay, it's my profile and then my profile JSON. And that's pretty interesting because we also added some automatic version skew handling. So the fields will be automatically converted into annotations and vice versa. So this means that we just can automatically convert already running workloads from the old behavior to the new field, which is pretty nice. And we also enhance the documentation, really, really nice. So we have a dedicated documentation site on kubernetes.io, which which gives you more information about profiles, how they can be crafted, and running some dedicated examples around it, which is pretty important from my perspective. So, but how to create such a feature in Kubernetes? Yeah, it's pretty interesting. So first of all, we had to find some people, and this was mainly involved. We had some discussions around, hey, should we build something like a Kubernetes operator so that we have something like out of 3 enhancements around those feature? And then I had a little chat with Dan, who was pretty interested, which is really nice. And then we also met Paulo, who was planning to work on a completely different feature. So the idea was to synchronize Seccomp profiles via the container runtime interface, so the CRI. And yeah, we decided, okay, do we want to do it as an operator? And then we decided to go for that way. And our discussions were around graduating the feature. And then we decided to work on the work on the graduation itself. What did we have to do for that? So first of all, we had to finish the Kubernetes enhancement proposal. And I can show you how this looks like. So we have Kubernetes enhancements. And there's the enhancement proposal. So Timothy did already some work around that, and we had to finish it. And you can see it's a lot. It's not only just adding a field to the Kubernetes API, it's outlining the graduation criteria and signing off the release checklist, and all those stuff has to be predefined. And this already took a lot of time. But in generally, I just can recommend to do it 1 release cycle before actually working on the release. Right now, we did it. I think we finished the document right before the 1.19 release cycle starts. And then we had to work on the implementation. So we had to work on the feature itself and also the version skew handling. So this can take a bit more longer than usually expected because we required API review, and it can take time if Kubernetes source code base is pretty huge, and to find the right place to put our source code in can always be a matter of days if we are not really familiar with the source code at all. And then we had to write some documentation around the feature. And I'm really thankful that Dan took this up, and it's really awesome. It looks really great. I'm really looking forward to link it if the release branch got merged from the documentation perspective. And then we had to work on the test implementations. So all those unit testing is just obvious to implement unit tests, but we also had to convert some end-to-end tests to the new field, and therefore to check the new behavior that it works as intended at all. So during our overall development, we found a lot of room for possible enhancements on the overall Seccomp work. So we thought about, okay, out of 3 enhancements will not actually require a cap, which is pretty nice. We already had some design discussions around the group, around our little group. We already share the same interests, and we were evaluating and iterating on probably features. And it's pretty easy to do that out of 3, and then decide if we want to bring a feature into Kubernetes and propose them as a Kubernetes enhancement proposal. So here we are. Yeah, welcome to the Seccomp Operator. That is the project. We now live in Kubernetes 6, which is pretty awesome that we managed to do it, because now we can use community resources and our CI/CD testing on it. And what does the operator do, or what is the intention of the operator? So we have a really limited set of features for our initial release. So first of all, we would like to enable config maps to store Seccomp profiles. Those profiles should be synchronized across all worker nodes. And we added 2 more features on top. We would like to validate if the node supports Seccomp. And if the node does not support Seccomp, then we do not want to synchronize the profile on the node. And we would also like to validate if a profile is syntactically correct, which basically means if we can unmarshal the JSON into a Seccomp structure. And if this does not work, then we will also not synchronize it. And that's it for now. We have a lot of more features where Dan will speak about in a couple of minutes. So now we basically can go to our demo. And what we have here is a running Kubernetes cluster based on 119 RC4. And there's not much running inside this cluster, so we just have kubedns, which is fine. So let's have a look at the deployment of the operator. So we have 2 deployment variations. So first of all, the operator is able to synchronize across all namespaces in a cluster, but we decided to add an additional deployment method, which just allows to focus or just bounce the operator to watching on one single namespace, just for security reasons. So if you prefer that, then feel free to use it as well. And the operator itself lives in its own namespace. And yeah, we have a service account, which is per default able to list and watch all config maps. And we will also provide some events for debugging purposes. So the operator itself, for sure, has a Seccomp profile, which got applied to the operator. And yeah, for now, we stick to the old annotation style because we want to be backwards compatible. But now we were thinking about how we can deploy the operator in a secure way. And the idea was to have an initialization container which just does some pre-setup, and then that the operator can run without any root permissions at all. So what we do now here is we create our Seccomp root on the node. Then we change the permissions of that operator root to be user 2000 and group 2000. And then we symlink them into the operator root. So for example, we have varlib kubelet seccomp, which is the default kubelet seccomp profile directory. And we have varlib seccomp operator. And we link them together that we are able to just operate on varlib seccomp operator as an unprivileged user on the system.
Yeah, that was one thing that stuck out to me. I think you either had an issue or a PR open to make it so we could write to this, the varlib kubelet seccomp, because before we were saying, okay, well, we'll just put the profiles there in the path where they're expected. But I thought the symlink was a nice workaround, right? So we didn't have to escalate the privileges of the actual operator itself, but we still got those in that path where the kubelet is expecting them to be.
Exactly. It's also the only way to work around this deprecation of the seccomp profile root flag from the kubelet. So otherwise, we were not able to go outside of this directory for seccomp profiles.
Mm-hmm.
Yeah. Okay. Then so we have some security constraints to the initialization, but it's not that interesting from my perspective. Let's look at the container image. And the interesting thing is that we tried really to have the highest level of security. So we run as user 2000 in group 2000, and we drop all capabilities from the container. We also apply resource constraints, and that's pretty much it. So the container image itself works from on a plane from scratch container image. So we statically build the operator, and then it just can operate on the node. All in all, for sure, that's a daemon set. I had to mention that we will do it with a daemon set. We had some discussions around that, but it was the easiest way for us to have something working on every node. Yeah. Then I think we have some default profiles as well. So we were discussing, okay, what can we do to have some strong defaults? And probably one of the mostly used workloads is something like Nginx. And we decided to craft a profile, an Nginx profile, and then we'll talk about how to craft profiles in a bit. And yeah, we now put them as default profiles into the Seccomp operator namespace as well. So I can show you in a bit how the file system structure looks like if we do that. So then,
yeah. One thing to note here is for folks who aren't as familiar with how Seccomp works, or if you haven't actually used it before, you don't really like recognize some of the barriers to using it, I guess. So I think one thing that's useful, if you look at that tutorial that we wrote up for the Seccomp site on Kubernetes, it talks about we're running a kind cluster, so it's a bit easier. But essentially what you'd have to do if you didn't have something like the operator is you'd have to go to each node and put these Seccomp profiles in a specific directory there, and then know that they're there, without a representation in the Kubernetes API. And then apply that path right to your pods. So you can especially think of in a like organization or something like that. That's really hard to do, right? Because usually someone who may just be, deploying a workload isn't going to know about what Seccomp profiles are present on each node. And also just keeping track of, if a pod can be scheduled to this node because the Seccomp profile there is present or not, that can be difficult. So as Sascha mentioned, this deployment here is a daemon set, so it's running on every node. So what it's doing is saying, okay, you can create a single config map, and we will put that profile on every node. And then let's say, you're running a workload, you can say, all right, kubectl get config maps with the seccomp annotation true. And you can see all of your seccomp profiles and say, oh, okay, I know this is present on these nodes. And then some other things, which I know Sascha mentioned we'll talk about in the future, is, maybe you want that on a subset of the nodes, and we'd like to add the ability to support that. Maybe you'd like to easier list your seccomp profiles rather than just getting your config maps by the annotations. So these are all things we have in mind. And, for our first iteration, as Sascha mentioned, we're not including these things because we want to, get feedback on them. But if you have ideas, definitely feel free to drop them in the chat, open issues, etc., on their repo. So yeah, I'll let you go ahead with the demo there, but I just wanted to point that out because sometimes if you haven't done it before, it's kind of hard to recognize the value that something's giving you.
Yeah, exactly. Thank you. Okay, then let's create our operator. So it should be fairly straightforward and it should work. So we create our deployment here. Let's switch to the so we can see that the operator is now running. We have a single node cluster, so we have just one operator instance running. And this is my my root user. I'm root user here, and if I look here, then we can see that we are on warlib here, and Seccomp operator created the directory here with user 2000. So I have to be root, otherwise I could not look into that directory. But we can see that the operator created the hierarchy. So we have the root directory, the namespace, then the config map name, which is default profiles, and then the profile. So let's just look at the deployment again. Here we can see the config map name, the namespace, and also the profile name gets synced to disk. So this works. And now if we want to deploy something like, we provide some examples. For example, we can have a look at our example profile, which is pretty straightforward. Yeah, let's do it just in the default namespace, I think so. We have 3 profiles in that config map. So let me just check that out and apply that. And if we now look at the directory structure, then we can see that we have our default directory, then test profile, and then all 3 test profiles synced here. So just to show that it's actually having the right contents in it. Yeah, so the default allow profile has the default action allow. So
I really like how this is structured too, because you know, based on the naming of the config map and that sort of thing, you can kind of like customize the path, and you know, you're going to be applying these in annotations or security context, as we'll see in a moment. But it's nice to be able to say like, I would like these profiles, you know, since you can have them inline in the config map. You have 3 here. You can say, I want these all under test profile, right? And then they'll have their names under there. So it's really, I think it's really nice kind of tree structure that we arrived at there.
Yeah, yeah. And here you can see the Seccomp operator profile itself, which will be copied during the initialization. And then there we have our operator symlink. And now let's just make some of those profiles wrong. For example, if we put it through here, then it's syntactically not correct. And if we apply that profile again, then we will see that, let me just go into the Seccomp operator directory. We will see that the default profile block has not changed. So, and if we now look at the events, then we can see that we have a new warning event, and it's not possible to validate the profile block.json. So it's referring our test profile config map. And then we have the error message that it's not possible to decode the profile, so that we don't have the right default action. And it does not map to an actual action, which is available on the system. But if we now change it back to something different, for example, now we change it to log, which is right, and apply the profile again, then we can see that it's actually applied and that it's now working again. So the synchronization is pretty much working. And then we also have a little example pod. So let's have a look at this. We have our test pod here, which is an Nginx. And we could use, for example, the default pod-based profile, like localhost operator, Seccomp operator, default profiles. So we would have to specify the whole path. And later on, we were discussing something like having mutating webhooks or something, how we could reference those profiles to the actual workload and sync them and things like that. But it's just future topics we were thinking about. But we are running on Kubernetes 1.19, so we can use the security context here. And let's just use the new security context field and the Seccomp profile, and we specify the localhost profile by operator / Seccomp operator default profiles, and then our Nginx profile. So this should work. And let's apply it. Containers creating, and it's running. And if we now describe this pod, then we can see that we have the annotation here. So the test container annotation has been automatically added by the version skew handling of the GA graduation of Seccomp. And we can see that we have the localhost path here with references the Nginx profile. So this is pretty nice, and it's working as well. And I think that's it for my demo. And now I can hand over back to Dan again.
Awesome. Thanks, Sascha. Yeah, that was a great demo, and you know, it's pretty easy to get started with this, as you can see. and we're definitely interested in making it even easier. What I want to show is kind of like a real world example, and obviously we talk about Crossplane quite a bit on this show, so I wanted to show actually crafting a Seccomp profile for Crossplane and the Crossplane package manager. And one of the things we're going to show here is how hard it is. So I'm going to intentionally and maybe unintentionally too stumble over crafting this profile because it is kind of a difficult thing to do, discerning all of the different syscalls that a workload is making. So we're going to go through that. Before we jump into that, I wanted to give some shout outs to folks in the chat. It looks like Adolfo has joined us. Adolfo works on the SIG Release team, and he is the docs lead for, or is it release notes? He's a release notes lead, I believe, for this cycle. So thanks for joining us today. And then Rob is also joining, and Rob is on the CI Signal team with me. So excited to see you guys here. If any other folks in the chat, definitely feel free to let us know. All right. So, as I mentioned, we are going to try a few things here. Let me get ready to share my screen. All right. So desktop 2 here. All right. So you should see my terminal now. And so I've got the Seccomp operator here. And I'm going to deploy it in the same manner that Sascha did. I'm going to also have Crossplane open, and we're going to look at the Helm chart and what processes are actually running when you install Crossplane, and then try to build some profiles for that. So I will first start off with installing, well, actually what I'm first going to do is create my kind cluster. So I'm going to use the actual kind config that we use for our end-to-end tests, which is going to emulate a cluster with 1 leader node and 2 workers. So we can kind of see that synchronization. What Sascha just showed was single node. So we got to see that those would be put on a cluster with a single instance of the operator running. Now we'll see the operator running on different clusters and see the profiles sync to each of those nodes. Sorry, on different nodes, not on different clusters. So let's look at what the kind config looks like. You'll see we just have 3 here. I'm going to be running 1.18.2 nodes, I think, is the default right now. And so we'll be using annotations for the Seccomp profile as opposed to the new security context. All right, so I will start off by creating my cluster, and we'll use that config as I mentioned. Kind config.yaml. All right, so that's going to be getting spun up for us. And then after we do that, we will install the Seccomp operator. While that's happening, let me go ahead and open up to Crossplane here. So I have some profiles here, but before we look at that, I first want to look at what we're going to be modifying. So in Crossplane, we have the main chart here, and I've already built it, and we're going to do a local install of it to be able to incorporate some of these changes I'm making. But the main 2 things that run when you install Crossplane is core Crossplane, which allows us to compose our managed resources and allow you to define new API types and that sort of thing, as you've seen on previous shows. And you also have the package manager, which installs new providers for you and adds new functionality to your cluster and that sort of thing. So these are just deployments here that are parameterized via Helm charts. So you'll see that I've added some annotations here to the Crossplane deployment. So like I said, we're using 1.18, so we're going to have to stick to using annotations here. In this case, we're actually only going to be using this one profile because I'm setting the pod level, but that's going to be overridden by the container level profile, and we only have a single container here, which is the Crossplane process, and it'll have the name of chart.name. All right, so let's see if our cluster is up and running. It looks like it is. So I am going to go ahead and install the operator. So I'm going to do where it's watching on all namespaces. Sascha mentioned actually this morning we merged the ability to run it in a single namespace, which allows you to restrict your cluster roles to just be roles and role bindings and only apply them to a single namespace, which could be advantageous in some situations. All right, so we see those get applied. and you'll see they're initializing. So it's doing that step, that bash script that Sascha showed in the deployment. One of the things that's really nice about doing this with Kind is it's really easy to get on these nodes and see what's there. And this is actually the strategy we take in the tutorial that's written up for using Seccomp on Kubernetes, which will be live once 1.19 is live. So if you're running Kind, you can always just look at your containers. So you'll see we did a 3-node cluster. So we have the control plane and then both of the workers. If you remember, what Sascha was showing is that we first have that seccomp profile, which is for the operator itself. That is not getting reconciled by the operator because we write that to a different location, and it doesn't have the annotation on it. So I don't know if folks caught it when Sascha was going through it, but for a config map to be considered by the operator, it does have to have this annotation on it. So basically, we don't want it watching for all config maps and saying, hey, this isn't a seccomp profile, when it's not intended to be, of course. And then also, if you're running with a specific namespace, that config map would obviously have to exist in that namespace. All right, so we do have some default profiles, that Nginx one that Sascha showed. So if we look on any of these nodes here, we should be able to see that present. So I will quickly exec into one of these. We'll just do kind worker and make sure that that's present. Okay, so that's going to be in the var lib kubelet seccomp. Let's see what's here. So we have that seccomp operator.json. That's the profile for the actual operator itself, as Sascha mentioned. And then in operator, we should see seccomp operator default profiles Nginx. So once again, that's the same profile we're installing these by default. So if you have any other default profiles that you think should be present, that everyone could take advantage of, those are things that we'd be interested to add, that are automatically installed, and we'll likely configure, which ones you want automatically installed as well. One thing we were talking about before this, as I was crafting the seccomp profile for Crossplane, is that there's lots of things that run in Kubernetes that would need seccomp profiles that are probably Kubernetes operators, and lots of them use controller runtime, right? So for instance, the seccomp operator itself does. So having a kind of base controller runtime profile could be something that would be advantageous. And maybe we add a couple of other common calls that are around that. And the seccomp operator profile itself actually probably right now is pretty indicative of that, because as Sascha pointed out to me, it's basically just a very thin layer on top of controller runtime. So it's pretty easy to do. So anyway, we see that that's present here. So what we want to do next is create these profiles for Crossplane. So I'm going to have the Crossplane directory created, and then this crossplane.json and the package manager.json. And then these are going to actually be applied to these containers when they run. So I'll go ahead and kind of spoil the surprise for you here. These are the same profiles as we were using for Nginx. So I use that as kind of a base. And then went through and added on some of the other necessary calls that were required for the Crossplane operator. But what we're saying here is the default action is to have an error. So I'm telling you on the front that this is not going to work. So we should see actually these containers attempt to start and error out because they're making prohibited syscalls. So let's go ahead and give that a try. All right, so we'll start off by creating this profile. All right, and so it says that was created. What we'd like to see is that pop up here. So it should be in seccomp operator. We should see a new directory here, Crossplane there. And if we look in Crossplane, we should see both the crossplane.json and the package manager.json, and we do. And let's just make sure that looks how we expect. It does. So that's good to see. And we can go ahead and exit out of that. So we know that that profile is present. And now that it's present, we can now use that on the workload. So I'm going to, as I said, just do a local Helm install. But before I do that, I need to install a few CRDs here. All right. And then we can do a Helm template of cluster charts Crossplane. And let's just go ahead and kube control apply that. All right, so you'll see we install a number of things here, but mainly what we're concerned about for this demo is our 2 deployments. And what we should expect here is that we have errors on them. So as you can see, the package manager and Crossplane itself are errored out. And we can actually take a look at what it says. Sometimes it's a little cryptic as to why, but let's describe the pod and see if it gives us some good information here. Be good if I spelled kube control correctly. All right, so yeah, it doesn't give us a lot of information here, which is sometimes not super helpful. So, that's something more, I think, at the container runtime level, but essentially what's happening here is it's trying to make these syscalls and it's erroring out. So what I typically do is if I have kind of like a base profile that I'm working off of, is I change that error to log the syscalls by the default action, see what syscalls it's making, evaluate if those are things that it should be making, and then add those to the profile. So let's go ahead and delete our installation here. All right, so we want those to go away, and I am going to change these profiles to make the default action log. So if it matches, if the syscall matches any of these that we've defined, then we should not see it logged because the default on that is allow. But for everything else, we should see it logged, and we'll look at how you can actually see that. And it's really convenient if you're using kind, because you can just look at all of these calls in your local syslog. So if we update this profile, then we should see, once again, that I can't spell kube control. Okay, so if we apply a new profile, then the operator is going to go and update that for us on the node. So if we actually went back and looked, we'd see that, which I won't do because you can take my word for it and we'll see it logging here and that they won't fail. But you'd see that this was changed to log. So now, when we deploy Crossplane again, and we take a look at the pods here, you should see that they're running, right? So they're executing correctly, and they're not being restricted from running because we're not saying to error out if they make a prohibited syscall. But what we should see now is if we tail the syslog on my local, that we see some of these syscalls being made. So you can see them actually logged here. And there's some information about them. They're actually both coming from Crossplane because it's using the name of the container, which within their respective deployments are both named Crossplane. And what you can do is look at the syscall number here. And then you can go to a helpful website like this one. And you can look at what those actual syscalls are here. So we see 186, 149. So let's go ahead and take a look at what those are. It looks like, we can drag this down, 149 mlock and 186 is get TID. And so if we actually amended these profiles here, with those syscalls, we should see them updated, and then we could try and run it and with the error default again and see if it works. Since we are already 50 minutes into the show, I won't take you through all the iterations it took for us to get to this. But in the end, running it on log a few times and adding new profiles, you'll see that we ended up appending a few different ones here. So I think all of these were new potentially. So it took a couple of iterations through there to see the different syscalls being logged and add those to the profile. So you'll see that this one is default error, but it should have all the syscalls there. So we should be able to run it. And this is typically what you'll want to do, right? You don't want to just log them. You want to actually restrict them once you've determined the correct profile. So let me stop this real quick. And we will once again uninstall Crossplane. And then we are going to, this will finish up here. We're going to remove that profile that I was using. And let's instead use the one that has the default error. I think it's profile correct. And we want to default error, but have the correct syscalls defined. One thing to mention here is I started out for simplicity with a lot of syscalls already included. So there's quite a high likelihood that there are a lot of syscalls defined here that are not needed. So it's overly permissive. So narrowing that down is once again another act where you have to kind of iterate through them. And if this seems painful, it is. And that's definitely one of the things as we iterate on the operator, we'd like to add record functionality and that sort of thing to help you generate these profiles more. Because what we've seen from anecdotal experience and actually from users is that frequently folks will get really frustrated with this and just end up not using it, right? Because it's too difficult to maintain this. It's too difficult to understand what it's actually doing and to generate a correct profile. And so they end up just abandoning it, and that's not what we want them to do, right? Because this is a really useful security feature. So making security easier to do in Kubernetes is kind of the goal of this project. So with that, let's go ahead and apply this. All right, so we've once again installed Crossplane, and let's look and hope that, hold on. All right. Hope that these are running correctly. All right. I'm having a tough day with kube control today. All right, so it looks like they are running successfully. And if we go down again here and tail that syslog, you'll see that we're not logging anything, right? Because we don't have a logging behavior. We want to error out if not. So anyway, that's a way that you could craft a seccomp profile. And then specifically for Crossplane, not all folks are going to be using the seccomp operator, likely because it hasn't been released yet. But if folks were, we'd like to be able to enable this. So what we could do here is add that profile to our deployment and gate that as well as the seccomp annotations here with a flag. And I'll likely follow up after the show with this. And then in the values template, we just say, by default, turn this off, but then have a flag that says, override seccomp true. And then in that case, you'd be able to get seccomp kind of out of the box running with Crossplane. So it'd be a useful feature to add. And with the operator, you could actually configure that much easier than you actually taking this profile, putting it on all the nodes. All we have to do is add a config map to our Helm chart here. So I think that really demonstrates the immediate value of even kind of like our limited functionality release of the operator. All right. So that was most of what we wanted to show today. And we've already talked a little bit about kind of the future for the seccomp operator. And I think we can go ahead and say that tomorrow we're expecting on doing the first release of the seccomp operator. So you can look forward to that. You can try it out. I know Sascha is signed up to run that release. So we're excited to see that. But Sascha, we've mentioned a few things today about how we can improve this experience for users. Post the first release tomorrow, what kind of things are you looking forward to adding to the seccomp operator to make this a more usable feature for Kubernetes users?
Yeah. Releasing on Friday is a good topic. We will take that challenge for sure. One really feature I was looking for is adding something like CRD support. So we have to add something on top of the crafting JSON profiles. So we could probably abstract it in a custom resource, and then that people have an easier way to, for example, craft CRDs or profiles. So this is one of the things we really looking forward. And I think we would also like to have more default profiles on board, which is one of the biggest things, because that would bring really value into the community from my perspective. And I think we have a little mind map. Let me just share my screen. And the Seccomp operator, let me just go back. So the Seccomp operator, we have a little mind map in the README. which lays out some possible features for the future. And you can already see, okay, there's a lot of things we can do. Okay, let me just exit that page. And for example, build on profiles is one of the biggest topics we are already working on or started working on. Then the profile types around CRDs. And also there was something around metrics, for example, is a feature. Maybe we don't have to add it in the next version, but we're definitely looking forward to add a better metrics or eventing system. And also something like, what was it? The replicating localhost profiles across nodes. Is that what we were already working on? So we have something like, we were thinking about how do we, what should we do for race conditioning, or how can race conditions happen? So we could probably look into the future that if we add a profile to the node, then we would like to have a nice way to reference it inside a workload, not only by using the field or the annotation or the direct path. So we could think about something like, okay, operator, profile, Nginx, so that's pretty easy to specify, and the operator finds the right path and mutates the workload for us. So this would be that it's easier to actually apply those profiles. And yeah, I think there's a lot of work to do, and we are really happy. If you want to join the project, then we are scheduling regular meetings to discuss our ideas and what we can do in the future. And yeah, we would be really happy to have more contributors on board for sure.
Definitely. Yeah, I think that was a great overview. One of the things we were talking about earlier today is what maybe like a CLI experience, a kube control plugin could look like to help with some of these things. I think especially kind of related to some of the metrics, but more from like a operator based, interacting directly is, listing all of the containers that are running without seccomp profiles applied. What are all the seccomp profiles available? What nodes are they on? That sort of thing. Surfacing all of that information would certainly make it a lot easier for folks to use this tool.
Yeah, we have speaked a bit about how to record profiles. I'm also not sure if that's a feature for the next release, but for example, we could have a look into projects like this OCI Seccomp BPF hook, which, so many container runtimes already support OCI hooks. I can give you a little demo of that if you want.
Yeah, go for it.
So for example, this hook is just this little JSON file and a binary, and it runs the OCI Seccomp BPF hook binary, and this is an OCI pre-start hook. So the hook will run before the container workload actually starts, and it only runs if we put that IO containers trace syscall annotation on it. And it will use the content of the annotation to be passed to the hook. So now we can do that. So for example, if we run Podman and add the annotation, then we can specify, okay, trace syscall, and then we specify an output file, which is in my case, just my downloads directory and then profile.json. And what we do is we just echo test on an Alpine container. So let's do it. It works, it's pretty nice. So now in my profiles, in my downloads directory, I have this profile here. It looks like this. And here we can see that we just echoed test, right? So we already have some syscalls required for actually starting the workload or starting the container. So we will probably never will live without those syscalls. So if I now run Podman again down here and specify the seccomp profile as security opt and also run echo test, then this should work. Yeah, it also echoes hello world. This should work. Yeah, it works as well. Pretty nice. But now let's assume that we modify this profile, just reformat it, and we remove just, any of those. For example, if we remove the change directory possibility from the profile and run it again, then the container runtime tells us that it's returning an OCI runtime permission denied error. So it's not possible to change the directory, probably when changing in the root directory into the root file system of the container. So this does not work at all. But we also don't have something like, let's just go into that container and use the real profile again. Oh my. Oh, it's not responding anymore. That's interesting. Yeah, I mean, let me just close that. Okay. Yeah, this doesn't work because, okay, I have to, let me just record it again. For example, we can do it like this. And then do some stuff inside the container. And now if I do an RMDO, for example, and RMDO wasn't part of the original profile, and we remove one of those directories which are not necessary, or let's just create one and remove it again, and then go out of the container. And now let's just look at the profile again. And there we can see that we have RMDO now in the profile. And we should also, we also have MKDO in the profile as well. So that could be a way how we can craft profiles. So with that hook, we could utilize the annotation to put some workload into something like a recording state, then record the profile on disk, and then apply it to a workload if we want to say, okay, now it's in secure state, something like this. But it's just, everything is just experimental, and we are not rushing for features in the operator.
Yeah, for sure. That's definitely a good example of a good way to do that. And with everything we do, especially because this is a tool intended to increase security in the cluster, we try to be very careful about, introducing new things that could potentially escalate privileges and that sort of thing. So yeah, I definitely think that's something we would like to support in the future. We did have a question here in chat. It looks like, is it possible to have fine-grained control over syscalls in terms of allowing, disallowing syscalls based on specific argument values? I'm not exactly sure what that's asking, but I'm not sure if it's argument values passed to the process that's running. But you obviously can allow, disallow in the profile itself, as we were showing. So we were showing mostly, I guess, allow. You could also have, a deny list as well, have a behavior for that. And then if you're speaking about like, changing the behavior of a process based on the arguments that you pass to it, I think something that Sascha just demonstrated there, with like the different commands he was running, is a great example of the different, syscalls that change based on what's happening in there. And if that's being modified by the arguments you're passing in, then you'd probably need to test out what that looks like. So hope that answered your question. If not, feel free to follow up in Slack. And that's a good thing to mention. There is a Seccomp Operator channel in Kubernetes Slack, so feel free to jump in there. And we're all there hanging out most of the time. And so, yeah. Look, it looks like Adolfo also asked a question. Using the eBPF to record the syscalls will record all calls the binaries use, or are they only recorded when they actually do the actual calls? I believe it's when they do the actual calls, right?
Yeah, and that's the tricky part, because
Yeah.
how to find the right path inside the binary that actually triggers all syscalls. So
yeah, you can do some, if like if you have information about how the language works, right, then you could do like static analysis of source code, and try to make some guesses based on that. But honestly, that's still kind of like a faulty thing, because you don't know exactly how something's going to behave when it's running. So you can get good ideas. I think that's kind of like the main takeaway from this, is that crafting these seccomp profiles, there's lots of ways to figure out some information, but there's not like a de facto, this is definitely what you want. There's a lot of trial and error, which is something that we'd like to try and eliminate there. Well, cool. I think we're at time pretty much now. So we can go ahead and wrap up here. Sascha, I just wanted to give you a few moments, if there's anything related to this or not that you're working on, and you're excited about, or anything you wanted to mention. I know, the Seccomp Operator being released tomorrow is kind of the big thing that we're excited about. But if there's anything else, just want to give you a minute or two to chat about that.
yeah, it would be really, really nice if we can actual get feedback from the operator side to you. If somebody has any project where you can use the operator in production, then it would be really nice to provide us feedback. Yeah, this would be really nice. I'm also pushing for bringing the operator into our products internally inside the company. But yeah, we just have to find the right use cases if we are on the right track or if we are developing in the wrong direction, things like that.
Definitely. Yeah, I totally agree, and we'll definitely be pushing this on the Crossplane side as well. So hopefully some folks can give us some feedback there. Well, Sascha, I appreciate you coming on today. It's definitely our privilege to have you here, and I hope this can be a resource both for some folks who are interested in making Crossplane a little more secure, as well as folks just interested in using the Seccomp operator. And like I said, please feel free to reach out to us on Slack or Twitter or GitHub with any questions y'all have. Otherwise, everyone have a great weekend and a great KubeCon. Yeah, we appreciate you joining us today. Everyone have a good one.
Thanks for having me.